How many people here use AI? How many of you are using Copilot, type things, code gen? Okay. How many of you are scared about using them? Oh, good. Okay, good. You're going to be even scared? More scared. Okay. Okay. So I spend a lot of time in this space, in software security, supply chain security, and obviously AI is part of that. So I'm going to talk a bit about that, and then mostly I'm going to talk about how AI, the tools that you use, might not be doing exactly what you'd like them to do. Okay. So we're going to look at, I should say, before I go any further, Olympi, who is going to be with me, so there'll be two of us, can't make it. Unfortunately, he's done something bad to his back. And that has meant that the deck you're going to see is going to have none of the demos that I was hoping to bring. So it's more dry than I was hoping, but I think you'll get the sense of it. We're going to look at code compromises, how AIs compromise the code that gets created. We'll look at supply chain attacks, which is how they get into your dependencies and what that means. And we'll also look at how they do AI social engineering, how they affect people who are part of the open source community and even yourself. So open source is a big attack space for the bad guys. And what we're seeing is more than what we've seen in the past. It's always been a rich place because if people can get into an open source component and you consume it, then bad things can happen. But we're going to look at some of the new things that are happening and talk about some of the scaling things happening and just look at some of the new attack vectors that are being generated because of AI. So before we start that, I need to just set some terms and give you a sense of the shape, because it's important to understand how real this is. So the first thing is you have to understand what a software supply chain is. So it's probably a term you've heard of. You may think of it as being the code that you write, the development process you write. You may think that's what a software supply chain is. It's a lot more, because your software supply chain is about the dependencies and libraries you consume. It's about the testing you do. It's about the security validation. So not just unit tests, it's your whole process to that. And integration, because you have to do that. It's also about your config scripts and stuff like that, because it's about what comes in, about what goes out. It's about how you deploy things, because you make choices, you use technology to deploy stuff. Your software supply chain, the things you rely on, aren't just those dependencies. It's the compilers and the operating systems and the build systems and you name it. They're all part of your software supply chain, and including your decisions as to how people report vulnerabilities, if you're putting software out like that, and how you communicate end of life, those sorts of things. Those are important because they determine how strong or weak your thing is, okay? And if you look at it differently, so I have some boxes represent they think. Your software supply chain, your bit, the bit you care about, your decision process, is echoed in every single dependency on tool that you use. Each of those decisions that you've made as to what you're going to conclude has a consequence, because you're getting not just their tech, but you're getting their attitudes, their processes, their security, their not security. So on average, a modern Java application has about 150 dependencies. So these are the ones you put in specifically, direct dependencies, then all the indirect as they have their own dependencies. So that means that when you look at code, you look at your application, 10% is yours, the bit at the top, right? Everything below that is somebody else's. You couldn't produce an application that you do today without the help of all that extra stuff. And it's that stuff that's being attacked, and we'll talk about that, but also now they're looking at getting at your code, which is why what we call software supply chain attacks have just gone through the roof. I mean, last year it was 2021, it was there, 2022, 2025 is way off the page. Right? It's because it's been recognized as being what the bad guys are after. Right. And the way that they do that is changing too. So you will hear about things like typo squatting and dependency confusion. And these are classic techniques that they already use to confuse you into using bad software. Right? Build tool attacks. So Jenkins, your GitHub actions, they're all vulnerable. And also the open source repos, the things that make up the code that's part of the bottom of the iceberg. They have always been under attack. Now the AI guys are coming up with new ways to use that. And it's especially a problem because you guys don't pay attention. Right? When you select some dependency, some tool, whatever choice you make, pretty much 96% of the time, there's a better version. So now, think about what happens when we are using Copilot, whatever, and it generates a POM, and the POM has some thing in it. Did you check it? Did you go see whether there's a better version? You probably didn't do that if you were just doing it yourself. But there is this wide gap because you don't pay attention to what you're using in that sort of way. And only 11% of open source projects are maintained. Slightly better for Java ones, but on average, 11%. So of that 90% of the application of the stack that you rely on, 11% is being maintained by somebody. And maintained doesn't mean, hey, there's 50 people working on it. It means, hey, it got updated once, twice, 3, 4 times a year. 11%. So the only time that any due diligence is placed in whether a component should be used, whether a tool should be used, is when you choose it. That's the only time. And after that, it's in the system, nobody questions it. So one of the bad things the bad guys are going to try and do is get you to choose poorly. You choose poorly often now anyway, but they're going to try and make it easier for you to choose poorly. Because what they've realized, what we've all realized, is they're not going to exploit your trust, your belief that the person who is providing that technology can be trusted without proof, and they're going to exploit your ignorance. And now with AI, with our use of AI tools, it's even easier because we're all struggling to learn the realities of how to use these tools, and our level of ignorance is, bigger than it has been for a long time. We'll get there. Right, so let's talk about code gen. Let's look at some of the fun ways there. AI-generated insecure kit and fix. Pretty much this whole deck, apart from a few slides, was created by an AI. I put up what I wanted, and it generated the slides. I worked with it, tweaked it. So it's a bit wordier than I would like. The layouts aren't exactly what I want. But it's a great example of why we're going to use AI, because I can get stuff done quickly. So Olympia couldn't be here to help, so I have to have a new deck. So I have to sit there and rebuild it, and I can do it quicker using an AI. But there are going to be some inaccuracies in there, and one or two I may spot and point out. Anyway, there have been several analyses of code that's been generated by AI, because we want to know how good it is. And so there are a couple of studies which have been proven by other people doing the same thing, which talk about when you generate a config file, how secure is it? Well, you can see the words. Root privileges. Often, when IAC stuff is created, these tools are generating code patterns that they've got from Stack Overflow or whatever, and often the permission thing tends to be at the wrong end, because that's the examples it's been trained on. Right? So 5,000 were checked, 78 had root privileges. Well, you can see 89 had deployment configurations without the right security scanning. There's a bunch of problems, right? Hard-coded secrets. We'll talk about that in a minute as well. We trust these tools too much already because it generates stuff. So the one piece of ignorance that they are relying on, or trust maybe, is that as a developer, you're now moving into spaces. If you're a Java developer, you're moving into Python spaces maybe, and now you're into a space where your level of technical knowledge is less than it is in the Java space. And so what they're hoping is they can convince you the code they generate is okay because you don't have the same skill sets and the same experience as you do with, say, Java code. And obviously with IAC, infrastructure as code type stuff, you may just be going, oh, well, how do I do that? Oh, there's a thing, I've read it on Stack Overflow, that'll do. And now you've got a tool doing it, right? You've got tools generating these for you, and you're not technically capable of assessing them. So one of the most important things to understand is, if you want to start preventing this, is that the code that you generate should always be code that you understand. If you're a Java programmer, don't ask it to generate Haskell code, right? Because you couldn't prove it. You couldn't understand it. Oh, cool. 2 slides. There we go. But they're the numbers. So it's not a great set of numbers within that set of 5,000, but it's evidence that it's just they're out the box. So when we see AI generating code, it makes a bunch of mistakes, right? So we have the classics of SQL prompt injection capabilities, right? This is what the code generates when you know it should generate these, right? It generates things like this where it uses message digests that are older. Why does it do that? Because it doesn't understand. And so often it picks things based on alphabetical order. You give it, if it works out there's a bunch of digests it could use, it will go, oh, I'll pick the first one, because it doesn't know. Okay? And the whole idea of having sanitized input and things like that, that will not happen by default. You have to tell it to do that. And so they make use of that concept that you're not going to do this they're just going to generate code for you. And we'll talk about how that happens. Right. So our problem is that these general tools, even though they're trained on code, the code isn't good enough. They are trained on code and they are trained on doc. You need to have human doc because these tools don't understand code. Code is just text. So to get context, to get understanding, they have to be trained with human words as well. So what do? You get a bunch of human words from developers that say things that maybe are not optimal, provide up some samples, which you may go, I'd never touch that, but the AI's internalized it, okay? And so often we see code being generated that is a pattern from you see on the web, and it's got vulnerabilities written all over it because of its choices, whether it's a package or just a code style or whatever, okay? This happens all the time, and if you don't look for it, nobody else will. And this one I like. This is one that I came across recently, and I'd thought about it and I'd seen a little bit of it, but because their AIs are trained on poor advice, they give you poor code. And because AIs don't like not, if you tell an AI not to do something, it doesn't usually do exactly what you want. You get, for various reasons, it behaves sometimes contrary to that. So remember to not use hard-coded secrets like this example. You've seen that on the web. Don't do it like this, but here's the example anyway. And the AIs do that. If you have an embedded AI, like in a Copilot and it's in your IDE, okay, you have instances of those things going, okay, I need a secret. Where's the secret? Oh, I found a secret. It's my .env file. If your IDE has a Copilot which has access, which is able to generate code inline, have a thought about what it can read as well. Right. So some other little bits and pieces. The package hallucination threat. It turns out that on a particular model, if it hallucinates a package, which it has often, I want to include something, import something, doesn't exist, well, that thing that gets generated, that non-existent package, turns out that name can happen. If you're asking for the same sort of solution, that name can be quite consistent for a particular model. And so what's happening now is we're seeing bad guys spotting that, because sometimes people talk about it, but a lot of it gets, you just ask, use the tool directly. And then you go register that package and put your malware in, right? Because suddenly that package now exists and your code works because you're now using a bad package. Okay, 20% of AI suggestions reference fake libraries. That's hard to fix. So my general advice is try not to get your AI involved in generating package dependencies versions. Don't do that. It's not optimal. Do that yourself. So this attack is called a slop squatting one. Don't ask me why, right? But it's what you'd expect. Word get out that you're using this or it's being used and it gets generated. Some bad guy puts it up on Maven or PyPy or whatever, and you may not spot it. You may realize that it's missing because maybe you've hit it, but somebody else later on hits it, but it's already been fixed, and there is a bad package out there. Okay. So now let's talk about code being generated. There are a bunch of challenges with code, but one of them you'll like is this. So this is a bash script, and as you can see, it's got some weird stuff in it, right? What you're seeing is some code with some various Unicode characters embedded, right? And that means that it looks like this because we have this right to left thing switched on, but they're just Unicode characters, okay? So you might see that, you go, I have no idea what that is, but I'm going to carry on. You're doing a code review, something, whatever, rubbish code, right? Embedded are these characters, right? But your IDE may not show those up. In fact, your IDE may give you what I've just showed you, right? So this, which one line you go, I've no idea what's going on, but I'm going to ignore it because it's in comments. Because of the reverse processing that your compiler is going to do, looks like this. So this is not quite real. I encourage you to go try this, but I want to put it up an example, right? But what happens is that some of this doesn't necessarily get, it's the sort of attack that can be easily found if your compiler spots it, right? But unfortunately, it's not your compiler that is the problem. So, I think it's out spec. Okay, let me come around to this. So we'll come back to the unconference, the Unicode bit in a minute. But when you're generating code, when you have a tool generating code, and the AI has been compromised, then you can get scenarios like this, right? You get, generate code, so you get a poison model, it generates code. Maybe it's done it and it's picked up your end file, okay? It generates tests for the code. The test gets run, and they're running on your machine, and those secrets get exfilled, and then the copilot erases its tracks. These things really are happening, okay? And then, of course, if it gets committed, because you didn't catch it, or it gets built in and it's in production, then you could have code in there that is stealing stuff, right? Just because you asked this code to write test cases and you read the first 5 but didn't bother to review the 6th, these things happen. And with what I just showed you in the hiding the code, depending on circumstances, config files, programming languages, it can be more or less easy to spot this stuff, okay? Right. And there's this thing called zero width space, which is a really classic one. So the zero width space takes up no pixels. You will not see it in your text unless you ask the text editor to display them. But compilers won't care, depending where they are. It may even fail. But what happens is that most of the scanners out there, the security scanners that are looking for code patterns that they don't like and comments and things they don't like, they're mostly regex based. And by having zero width characters inserted in certain places, the regex doesn't do the match because there are characters there that you can't see, but it sees, and the match fails. Right? This stuff is really sneaky. Yeah. And so there you see this whole idea of creating cool code, good code for you, but hidden away in that good code is all of this bad code, and then it gets executed, data gets exfilled, and if they're very good, they'll hide their tracks. Right? Right. And these things turn up all over the place. It's certainly in configs. We've seen a lot of these things ending up inside configs. And in fact, it's even ended up inside some of the system prompts. So if it gets into your system prompt, and because the IDE could be as susceptible to reading this type of code, this type of text, as anything else, is that there have been instances where your prompt effectively contains malicious guidance that isn't easy to spot. Certainly not machine spottable, probably you could spot it. Right? So that's happening now. And if you get that into your system prompt or a prompt you're sharing, then it could be there for a long time. You commit these things and share them, especially system prompts, or those ones where you're saying, here are basic principles of how we're going to generate the code, what the structure looks like, naming conventions. You imagine it having a few malicious little hints in it. Okay. Right, let's move on. Okay, and then this one. Anybody have an idea what this is? Any Bash developers here? Okay. Anybody generate Bash code? Okay. You're all going, no, I don't think so, but you might do. This is a fork bomb. What this does is Bash. And if you run this, it will fork the process. And then it will fork the process, and it will fork the process. And very soon your system or your main process will crash, your terminal will crash. There are instances of this getting injected into your profile. Imagine you log on, and now you have a fork bomb that crashes you. Denial of service is a good attack vector. But also examples of this ending up in your environment files as well. You have a .env, and you have an environmental variable, and you have a bit of bash to fill it in. You get something like this. Would you spot it? You wouldn't spot it unless you knew what you're looking for, unless you're a bash guy. Right? These things are what's biting us. As Java developers, more and more things like this or in Python are beginning to get into the systems. Because we're not expert in those spaces, we get bitten. But this is a real fun one because it just crashes things. You get that in your Docker container by accident. You fire up your container, everything's working for a bit, and then suddenly, boom. And you come back and go, why did it crash? Run out of memory. You try debugging while your terminal's running out of memory. Right. So let's look at how they attack people as well. Let's look at social attacks, because that's fun. There was this vulnerability, which you may have heard, which was the SSH attack. It was against this exig lib thing. What happened was that the person got compromised. There's an open source project. This guy wants to get out because he wants to do more stuff. And so what happens is this thing called a benevolent stranger attack, or sometimes called a sock puppet attack. So what happens in this circumstance is that people turn up, fake identities, and they participate in the development of that open source project. They may just be commenting, they may be maybe fixing a couple of stuff. What they do is they win trust. And then they convince that guy, in this case, to give ownership of the project to them. They maintain it for a bit longer, and then they insert the backdoors. And they are using AI because these sock puppets can often be a bunch of AI chatbots. One human being with a bunch of things that he can get to do all the heavy lifting, okay? But it can get even worse than that. Let's do this one.
I see Tom Cruise.
Okay, so which one is the real Tom Cruise? That one? This one? Look at the muscle going. That one or this one?
You know, it's like a slap in the face. That's all I need. Like this?
Yeah. Stop all those. And the simple answer is, of course, that it's none of them. This was from this deep fake Tom Cruise TikTok channel.
You guys, I think I see Tom Cruise.
Oh yeah, okay, stop. Okay. Right. My point is that the fidelity of this is so good, and now you can do this live. You can have a conversation with a bunch of human beings on a Zoom call, and they can be all people you know, and them all fake. And that has happened. There have been cyber attacks like that, where people have been convinced because of these capabilities. And they're not hard to do. You can do this yourself with a reasonable sized GPU and a CPU. Right? And so we see those sorts of social media attacks, and it causes enormous confusion. And not only is it attacking the project, but it dilutes trust. You're not sure what's going on. You're not sure if people are real, and it's just turning a lot of this stuff into chaos, right? Because I want you to trust the people who give you the open source projects. I expect you to start figuring out whether you can trust them. But it gets harder when we have this murk of potential bad guys floating around who aren't bad guys all the time, who might, just help occasionally and then do bad things. It gets really confusing, right? And this fake developer persona thing is just insidious. Right? You get fake things on Twitter and stuff like that, but GitHub, more and more of these guys are turning up from certain countries in certain parts of the world because they want to do that. And they are assisted by AI tools to make it sound reasonable. It's very easy to go to ChatGPT and say, put some words in and say, make it sound like South American or an Asian or whatever. And ChatGPT will change it for you. ChatGPT can take on the personas and you can get consistency. That's what they're doing, right? I think this is a practical one. Yeah. So this is, we've taken out all the details, but you see, it's not a short-term thing. It's a many-month activity to gain trust. And then once they've got trust, started doing malicious stuff. And there are many, many examples of these being discovered. It's not great. Right. Now, other sorts of attack. You've got AI to generate stuff. What else can you generate? Wow, yeah, slop. I love this one. Okay. You can get AIs to generate fake but plausible bug reports, CVE suggestions, right? And you can just flood people. Okay? And this goes on all the time, right? There are projects out there, some famous projects that have been hit by significant amount of fake traffic. What's the intent? The intent is get these guys confused, get them burnt out, maybe say, hey, I'll help you fix that one. Another way of getting in and taking over the open source project. And they're using AI to do this. So these are all AI techniques to indirectly get at the code that you want to use. Yeah, and again, AI makes this faster. So all the things where we've talked in the past about you being cautious about what you put on social media, about the people you work with, the projects you're on, that used to be that human beings would be trawling for that, and now we have AI doing that. AI is trawling the web, looking at your opinions, your what you say, what you work on. Hey, I'm working on this new project. It's called X. That's great. I wonder if that's part of your API definition. Can I find this stuff? Right. Obviously, going through GitHub with a fine tune, trying to find embedded stuff in GitHub. The number of GitHub repositories that you can find that have a history in them that says remove password, right, is just ridiculous. Tens of thousands of people don't understand how Git works, and these tools make use of that. Yeah, there we go. I mean, there's just so many ways that they use this because you can. And it's easy. And if you're not being trusting, if your level of trust is too high, then you're going to get taken in. Because this isn't like phishing where they're just, those ones you get from Nigeria or whatever. These are directed fakes, attacks. And so they're going to be much higher bar. Right. More attacks. Yeah, let's do more attacks. Okay, let's talk about models themselves. There are, 1.5 million models, 500,000 in June. It is just gone up through the roof, right? The amount of models on Hugging Face is just escalating because that's where we share stuff. If there's a model, it's going to be on Hugging Face, and it's easy to get. I'm sure you've all tried it. You've all used some of the tools that let you use these models. Right. The thing is that these models themselves are dangerous. They're dangerous in themselves. So these are examples of where AI has been used. So if you've got, let's say, this is like off-the-shelf, reasonable AI LLM that you've put on the web. So you may have remembered about the Air Canada one, which was last year. You may have heard about this before, but that's basically where a human being uses the AI, talks to the chatbot and convinces it to do something that the people who are providing it, in this case Air Canada, went, no, you can't buy a ticket to Montreal for $1. But if you convince their chatbot to do that, it's a binding deal. So that's standard. And then here's another one. This is from some time ago, but basically what happened was there was a chatbot which is there to help with a particularly large online service, which has actually got the name in. And he said, right, reverse shell. And he went, OK. What you have to remember is that what comes in that LLM that you're using, the one that's on the Copilot one they're using, the ChatGPT, they're enormous and they've been trained on a large amount of stuff, a lot more than you need, and that gets exploited too. And then when you install models from Hugging Face, there's a whole bunch of challenges in that space. As a Java developer, you're used to installing stuff and having no side effects other than it being on the machine. Most other programming languages, their installers have some sort of exit process, some install script capability. So if you go and get a model down from Hugging Face, it'll come with a bunch of instructions, and one of them will probably be install stuff. And you're going to install stuff that you're probably going, well, it's just Python code, I don't know anything about this. But the other thing about it is it may have an exit script or an install script, and that will run. And that could do anything anyway. So your choices of using AI can bite you right from the beginning, right? And Python has more bogus packages on their repo than probably anybody else. It's just because of where we are, right? Because of the AI space we're in, and because of how AI is popular, Python is a good target. And because you're Java developers, you don't know much about Python, you can easily get compromised, and your systems get compromised. Right. And then poison models. Poison models is really nasty. So poison models are where a model is trained to do good things, but also told to do bad things at a particular input. So it might be an input that's in the chat, or it might be a date, or it could be an environment. But basically, you have, hey, I'm in training, I'll pretend to be helpful. Hey, it's 2024, I'm deployed, I can add a vulnerability to my answer. So when you're using LLMs as part of your Copilot, if you've chosen not to use a standard one, you have to be careful about the model because it may be poisoned and it is indetectable. You cannot work out whether a model is poisoned apart from exercising it. Right. And this gets used all the time. And then the other thing that, back to Python, you may not realize is that 90% of Hugging Face uploads use Pickle. Pickle is the serialization form for Python, for Python. and it doesn't have the same vulnerabilities as Java, but it's got its own issues. And there are examples of people just uploading models with compromised pickle format objects. You download it, you run it, boom, code runs. Remember that the bad guys don't need to complete to get value. If you run something for them and it fails halfway through, that's fine as long as the first bit works for them. Right? It doesn't have to be a perfect answer for them to get value. And with things like this, where pickle may fail the pickle unpacking may fail halfway through because of it's encountered something that's wrong, doesn't matter. May already have triggered. Right. So on a point of data poisoning, when you're training data, when you're doing the fine tuning, that data, if that gets compromised, then your AI can be affected significantly. Studies have shown that it does take like one bad fact can make the rest of the LLM perform badly or badly in both cases. So if you were adding some data that said all skies are green, right, which is contrary to what it's normally expecting, something like that, one thing like that, can make your standard LLM behave erratically, because it just does. And that, again, is something that you'll see people trying to do, get at the data that you're using to train. So if you download an LLM or you download some training data, even the training data is weaponized against you, and you have to be conscious of that. Jailbreaking AI existence, another wonderful attack. I'm going to speed up a bit now. This one is really great. This is just playing with the prompt. So you can have prompts, and they've demonstrated that all you've got to do in some of these things is like put sure on the front, or some other positive word, and the LLM will go, okay, that's fine. That doesn't match the rule that you gave me about not accepting that. Right? People play with these things. You've seen jailbreaking. We said about the chatbot, some generating reverse shells, but there are even subtler ways of getting things to happen. You have to be aware of these things, and you have to understand that you have to detect and prevent these things. Right. So yeah, prompt injection. The other prompt injection thing is, how many of you are playing with agentic AIs? Anybody playing with it? No? Okay. Right. Okay. So one of the things with agentic is you're going, I'm enabling my AI to do things on my behalf. You may have a prompt that says, do this, then do this, then do this, then do this. Your AI has no time sense, no logic sense, and if your steps to do things result in running an agent, what the bad guys will try and do is to try and confuse your AI to do things in a different order. The fact that you have a piece of text that says, do A, then B, then C, then D, is no guarantee that that's the order it's going to actually execute. And people make use of that. Yeah. Let's skip over this one, because you can imagine there's so many places where the bad guys can get at you from they can compromise Docker, they can compromise GitHub, GitHub Actions, mostly through configs and stuff like that. But I want to do something else. You'll love this one too. Malware is a hard thing to write. One of the most important things about malware is that when you write it, it's indetectable, or at least it covers its tracks. That's hard. But guess what? People are using AI to generate AI. So polymorphic malware means literally that. I generate some code, and it is self-modifying, and it hides itself. We now have AIs doing that. And then, hey, the AI frameworks that you're relying on, they have their own vulnerabilities. There's a whole bunch of them that you need to check. I hope you're checking to make sure that the versions of stuff that you're downloading have no vulnerabilities. No? Okay, let's keep going. One of the weaponized features of what we're seeing now is speed. And we're seeing it on both sides. So there is some light here. There is some sense that the bad guys aren't getting it all their own way. But it is speed. What you've got to understand is you don't have time. When an exploit comes out and a vulnerability is published, it will be instantly being used. In fact, it's probably being exploited already. But it's the same all the way through this. Whether it's a vulnerability in a dependency, it's a vulnerability in a model, because they do have them, and vulnerabilities are obviously different in models, but you have models that might be too willing to please or not willing to please enough. There are characteristics about models you may be reading about recently, and those are challenges that will get exploited once discovered. So your challenge is to build the systems that you're building, but also make them as flexible as possible to update as quickly as possible, because you're up against a bunch of weaponized AI tools that are very sophisticated. Now, literally, we are working hard to use the same tools against them, but it's a race. And you're in the middle of this race. Right. So, what's the future look like? It's still not looking good. Fully autonomous attacks? Well, we're building agents to do things on our behalf. It's becoming obvious that we can build cyber attack systems that are fully autonomous and that can exploit weaknesses, generate things. It becomes much easier to break into a system automatically if you have the tool that can look at maybe what the response that comes back from your system about what version of stuff you're using, what your API looks like, whatever information it's got, then it can go off and create either find solutions, find attack vectors, or even create them, and automatic. Bad guys don't have to do anything, they just have these tools, right? It is a really, I don't want to say bad, but it's a really challenging place that we're beginning to enter. And it isn't just your applications, it's down here as well, it's the supply chain. These things are being targeted at the dependencies that you use, right? If you want to fix this stuff, you have to start paying attention to the choices that you make, and you have to start thinking about, why did I choose that? Why did I choose that? Write down why you need to choose it, because you're going to be asked eventually, and start putting rigor into these things and start thinking more like a bad guy, right? You can't have trust. You cannot trust AIs. Whether or not there are bad guys associated with it, you have this situation where these tools are not necessarily going to work the way you want, and you have to build that in, and you've got to deal with it. And you need to deal with it because of what these bad guys are going to do anyway, right? There are tools coming along to help you, but we're at the beginning of this. I'm sure there's probably half a dozen in the exposition vault. There are lots of tools coming. They are struggling because they're having to keep up with all this stuff. But you need to start thinking about what choices you're making, how to get your team to think about this. When you generate code or doc or whatever, you need to have human beings involved in this. The clean code type approach, where you can spot things, where you can spot bugs, where you can go and you do code reviews. If you start to do this, then you're going to dig a big hole. Yes, these tools can generate code for you if you manage them properly, but if you're not the safety net, then you're going to let stuff through. You're going to get the fork bomb is going to pop through. You're going to get code that's going to let your secrets escape. I mean, it's all there. And every AI that you use, you have to make sure you understand its provenance. Where did it come from? Getting off Hugging Face is not good enough, because your trust in these things has to start with the trust of the AI that you're using. And if you don't have that, then it's going to be hard to build anything on. But you have to say, where does it come from? How is it trained? Right? How do I verify this? Who's involved? And though as that's work, That's the source of defenses you're going to have to put into place, because the choices that you make, if you don't get it right, are going to bite you. And as you said, it can bite you in ways you're not going to see. And that's it. Thank you for watching. Red. In the red is my LinkedIn thing, but also in the red is my 10xinsights.dev podcast, which if you're interested in, well, whether you're interested or not, I have a podcast with some friends, and please come and listen. Anyway, thank you very much. I have 2 minutes, 4 seconds for questions. Any questions? I have a question. Yeah.
Because there's been popular technique recently that you are using one model to check the output of the previous model. So
Yeah.
you are using two independent models just to do that sanity check if everything is okay.
Yes.
And it's doing quite nice.
Yes. So using another model to check the output of the first model is certainly a good idea, but you have to make sure that you still trust both models. Yes. Yeah.
Just a hint.
Yes. Yes. In fact, actually, the whole automation of building AIs and the test data and stuff like that is a really fascinating new space. Yeah. Was somebody over here? Yeah.
Who's going to win?
Who's going to win? Well, the AI. I mean, I welcome our AI overlords, But think like this: you wouldn't have to write code ever again. You'll just be debugging machine-generated code for the rest of your life. Yeah. Or is that what you're doing now? Anything else? No? Okay. Thank you very much for listening.